Um, this video is literally gonna be a bit more formal. I know that the formal, but I'm gonna try to phrase it as a problem. Today's date is the 30th of 30th of March 2026. The time now is 6 to 7 a.m. And the problem I'm phrasing is this: a lattice dome, a lattice force field. Basically, it's a subnet mask, a subnet space, subnet mask, force field or lattice. So a lattice includes order. A force field includes something that has a force and a field. And basically, it's a dome. It's a dome. A dome, D-O-M-E. I'm trying to model the dome. You get a circular dependency of a function. Now, the function are functors. They map onto functions. They're middleware. And you have 8 functions. In this case, you have a circle, and you have the mutual B sequence. So you're gonna have you're gonna have some stuff from the center, a circle, slice the pie. You're gonna have a tri. You're gonna have a triangular, a surface area. You're gonna have the opposite of the circle, the mutual B sequence. You can have so you can have an area of space like this. The circle. So imagine you have a circle and have points touching the axis like at intervals of 25 degrees. And then you're gonna flip around. Let's say it's actually 45 degrees, a acute angle. 45 degrees. You got 45 degrees of an angle, and you have a sector of that region. Now that region is 45 degrees. 45 degrees. Uh, uh, 45 degrees uh, divided by 360, which is basically 0.125 radian uh, times 180 times 180, which will give you 22.5 degrees. And that degrees basically, am I right? So you're gonna have a sector, X sector area. This is sector area. So the sector area is 2.5 degrees. If you have 5 divided by 360 uh, over the roof, so you're gonna have 25.5 degrees, so 22.5 degrees. And if you take this 25.5 degrees and you take it on the center, or you flip it to another direction of the center, you're gonna have rotation, and you do a rotation, a flip of the rotation. If you flip the axis, or you do a rotation of the center, you're gonna have minus 25.5 degrees of the area, and that's the regional space to map out the kind of function of 3 points, 3 points in the geometry. So you're gonna have two sector areas of 25 degrees, 25 based on 25, 22.5 degrees. And then you can now compute obviously these 2 points represent A, B, C, and D from the center of the radius onto the circumference of the circle. And the basically this is basically mapping out how functions A and B, C and D map into a geometry. Now, this is the flat sheet of paper, the more triangles you have, the more you can cover more region or space. So now these are two sector regions or space. Now, if you then compute uh, uh, the points from A, B, from A to A, B, C, D, A, B, C, from point A to C, D, you have an arc, and the arc will be 180 minus 225. 225 times 2 actually will be 225 times 2 times 2, 45 degrees. Now, what will be 180 will be the area between the angle will be uh either 45 degrees or because basically goes to the map this kind of triangle to a number of geometries. You're gonna have a kind of geometric orientation of the system. So basically, you are doing the rotation. You're doing the rotator basically. Because it's going to be an auxiliary system, so you have rotation as a mechanics in the system. So you're gonna have over 25 degrees. For 5 degrees, you have 22 points. 25. You have 45 degrees total. These 45 degrees are have region they haven't touched yet, and this will be A B C D E F G H G and H. Now G and H have also functions, but you also have them as A star algorithm. So it doesn't matter G and H. So you're gonna have G H A B C D a, B, C, D, E, F, and G, and H. And these are all functions. Now, the functions are A star algorithm. So they have an A star algorithm on it. So, doesn't matter if I'm translating from, if I start at and I'm heading to H, you just take the shortest path to H, um, uh, um, A star have you have the A star algorithm, and those are written subnet masks in a region space. So you can have like a kind of a force field, but it's like a metaphysical, it's like a hyperspace force field. So you can have someone that's out of your network region, cannot be connected to the internet, or if you're out of the network zone, and it's basically a force field, but it's basically a force field that stops you from getting someone out of your network region getting internet access because they're not in the dome, you're not in the subnet mask dome. So you get these functions A, B, C, D, E, F, but they have no, they're unilateral. They're unilateral. They have no order. I mean, am I using that word? They, they're unilateral. Basically, they are unilateral and they are not. They are unilateral. Am I using that word correctly? They are unilateral. Unilateral. So let me try the word unilateral. So the unilateral functions that define in the space and time of the kind of region. And because they're unilateral, they have a coherence. It's not about coherence measurement. It's just like they are functions that use Dijkstra, treat of Dijkstra closeness centrality to reverse stereo state. But the functions are a net. So think of another one. If you have a triangular prism, a triangular, very important to understand this, guys. Triangular prism, triangular pyramid, not prism. Actually. A pyramid can project, but a square triangular pyramid, you have the area and the dome, and you have triangular prism. So you can have the prism be half times base times height times length, half times base times height uh, times plus width, half times base times height is times L to the power of 3 times G times height, basically times elevation, times basically the times L times length to the power of 3. Basically, whatever the formula for explain on, basically, if you take an orange, if you take the same system and you move into kind of a surface area, you take the integral of you're taking the net surface area, the net cube, like, let's take a simple cube. Let's do the cube because, I don't want to use a cube example. It's not a dome, but let's try to use it properly. So let's imagine a cube, a square circle inscribed inside a cube, and a sphere inscribed inside a cube. Now basically you want the cube to touch all the surfaces of the cube, but you don't want it to touch the edges because the edges are variability points. Because those are spaces you don't because if you have the place is space of movement. Based on you can still access the network. And the goal is to have a system of region mapped as a kind of a force field map. So, it doesn't matter whether you can't get internet if you know your service to use it. So, the functions represent Dijkstra's closeness centrality, and the closest are locked into a geometry. And geometry is basically the circle or the sphere inscribed inside the it is just down. The sphere inscribed inside the sphere inscribed inside the square. And if you can have the air space, be inside and not get inside, that's progress. That's means your system has not failed. But there's other geometric. If you then shoot, if you have the net of the square, and the fold evenly, the wrap around the double around the basically the net is basically the surface area of the square. I mean, it's cuboid. And the cuboid is literally going to be used to project a double flap over the subroid so you can wrap around the ball and so basically if you take a knife sharp object and cut an orange, that's the shortest part between 2 points. That's the A star to the surface edge. But if you have a half dome and cut it in two, that's the shortest part between two network points. Two network points in the real world place. And the kind of a lattice will have to resolve the kind of network topology, because lattices are unilateral; they have no order, and some of them have you have an ordered lattice, you have a non-ordered lattice. But if you compare the lattices, there's some info that you share via order, via the properties of order, and that's what I'm saying. More formally, it's more less about the system, more about the lattice or order. I believe, because that's basically it's going to stop you. If you're subnet mask, original space division called subnet. So it doesn't matter what you see and what you do. So we're gonna have numbers. If you have address them. If you have some, if you this will work theoretically. If you have if we have a number 0, this is a closed loop, replaces the number 1, this is an open loop. So 0, you see a 1, replaces the 1, and this is something mask. This is what this thing is doing. So if you have a 2, you close it. You have a close loop. You have a 6, you replace it with 6. And this is called subnet masking, but because you can't decipher this, and you can't access this network topology based on this IP address. Doesn't matter what IP address you just use it, map the IP address via subnet mask and you get access to service. And that's basically geometry subnet masking, because it's a hooping system. It's not just philosophical. It allows you, if you're belonging to the system, you get the correct kind of marking. So, for example, the marking is very important to understand. It's not the genuine cause for expectations. So you're gonna have all the numbers 1, 0, 5, 6. Sorry, come pen run out of ink, guys. So you're gonna have 0, 1, 2, 3, 4, 5, 6, 7, 8. And every time you see a closed loop ring, like an 8, replace it with something, initially, you map it to something else. Whether it's 8 bits, 8 bytes, doesn't matter. You map it to the character set. Or, because it doesn't matter the order. You know what I'm saying? So if you have a 0, you replace it to 1, that's a valid position. If you want 2 maps to 6, 3 maps to close loop. 3 cannot map. Okay, 3 maps to nothing. 3 maps to nothing, because you need nothing organization. 4 maps to 0 maps to 1. 2 maps to 2 maps to nothing or 0, which is basically dash. 3 maps to 8. 4 maps to 4 maps to 9. 5 maps to 6. And 7 maps to 9. So basically, this is a bit of a number system. And basically, all the mappings here, but the mappings are basically unilateral. So, basically, you go to have the hyperspace, hyperspace, hyperspace. Usually, you got a wide connection and you got a non-wide connection. You have two types of spaces, so you're gonna have two types of spaces. You have two types of spaces, those guys. you're gonna have a hyperspace, but you're gonna have hyper. You're gonna have hyper region, and you're gonna have hyperspace. You're gonna have hyper subsection. And you're gonna have a hyper range, like based on like kind of the range of the span, and based on XY coordinate system. We're gonna have regional space that the system can protect your Wi-Fi connection. So you don't have people accessing it, and it's basically a regional space that you cannot access internet. You cannot access the internet, but you gotta work out kind of basically, or we can also know because you're away from that network as you go of this whole thing. But it doesn't matter where you are. You cannot connect to something in the system. It's usually a force field, the protection from network connectivity or issue. Thank you for watching this video.